So in squares and square roots, alright, what we will be really learning is the long division method of finding the square root. Alright. Now let's say we have number like 2,76,676 and we have to find the square root of this number. So the way we will find out the square root would be quite different from the prime factorization method. Okay, so first step what we do is we create pairs of digits. Now how do we create these pairs is we pair up the digits from the right hand side to the left hand side. So we go from right to left, right? So I make a pair of two digits. So 7 and 6, 6 and 6 and 27. In case at the end there is one digit left which is an odd one, not a problem, we take it as a single digit there. But we always start from the right hand side and pair up these digits. That's the very first step. Now after having done that, we start from the first pair of digits on the left hand side. That is 27. Now you have to ask yourself this question, that square of which number will give you a number less than or equal to 27?
5.
Correct. So 5 square is 25, 6 square is 36. So I take 5 into 5. So whatever is my quotient will come over here. So 5 multiplied by 5 is 25. So I subtract 27 by 25. My remainder is 2. Now what I do is I take this 5 and add it to itself. That's my third step. So 5 plus 5 is 10. Now the way I write 10 is by leaving one space for one single digit at the right hand side. Alright. Let's go through it once again. My step 1 is pairing up the digits from right to left. I create a pair of two digits. Alright. I take the first pair of digits from the extreme left. I ask myself, square of which number will give you a number less than or equal to 27? So it's 5 into 5 is 25. So I write it in this manner. Subtract it from 27, I get remainder 2. And I add this 5 to itself. So 5 plus 5 is 10. But when I write 10, I leave a blank at the end for one digit to be inserted over there. Right? Now my next step is to bring down the next pair of digits. Here we always bring down pair of digits. So my next pair is 66. Hence now I have the number 266. Now you need to ask yourself another question, and for that you can use a rough work column. Alright. 10 dash into dash should give you a number less than or equal to 266. Now remember, there can be only a single digit that can come, alright, from 0 to 9 in this blank. And whatever digit you put over here, you will put the same digit over here. So if I put 1, so it will be 101 into 1, right? If I put 2, then it will be 102 into 2. Correct? If so, likewise I need to figure out what will I put over here and multiply it so that I get a number less than or equal to 266. So what would that be? 2. Because if I put 3, I will get 309, which is greater than 266. So 102 into 2 would be 204. So I put here 2 and I put a 2 in the quotient as well. And this is 204. So I subtract it. I will get 62 as my remainder. Now this 2 I'll add it 202. So I'll get 104. Again I will leave a blank at the right hand side and then write 104. Now I repeat the same steps, same process once again. Now I bring down the next pair of digits, 76. And now I will ask myself this question. 104 in dash into dash should give you a number less than or equal to 6276. So what do you think would be the number?
6.
Okay, yes, let's look at it if 6 works. 6 6 are 36, carry 3. 6 4s are 24 plus 3, 27, carry 2. 6 zeros are 0 plus 2, and 6 ones are 6. So we're getting an exact value. So I put here 6 and 6 and subtract 6276 from 6276. My remainder is 0. I complete this step by adding 6 to this number, and it is 1052. Now, since there are no further pair of digits to be brought down and my remainder is 0, therefore I get my square root of 2,76,676 as 526. That's my answer. Now let us understand how we will find the square root of a number which has odd number of digits. So if they ask us to find the square root of 46656, that's 46,656, then I'll find it in the same manner as we did earlier. Let me make this one. Yeah. So I'll write here 46656. I'll start from my right hand side, creating pairs. So 56, 66, and you notice 4 is a lone ranger over here. Is alone. So doesn't matter. I take my first digit, that is 4. Square of which number gives you a number less than or equal to 4? 2. So I'll write here 2. 2s are 4. So I subtract. I get a remainder. Now this 2 I'll add it to itself, but leave a blank before I write 4 on the right hand side. So it will be 4 dash. Now I bring down my next pair of digits, 66. So 4 dash into dash should give you a number less than or equal to 66. So what digit would you put? If I put 2, what will I get? 84, which is definitely greater than 66. Correct. So we have to go a digit lower and check. So 41 into 1 is 41, which is lower than 66, and we have no other choice then. So 41 ones are 41. So I subtract it. I get the remainder as 25. Now this one I added to 41. So I get 42 and I leave a blank at the end. Now I bring down my next pair of digits, 56. So now I'll ask myself, 4 to dash into dash should give you a number less than or equal to 2556. Now see here, you can look at two things. One is the first two digits and the last digit. So if I look at the first two digits of 25,
6.
then 4 6 are 24 is the closest. And I look at the last digit. So what digit multiplied by that same digit will give you a number ending in 6? So it could be either 4 or 6, because 4 4s are 16, 6 6 is 36. But 6 is a better option because 6 4s is 24, which is closest to 25. So let us try this. 6 6 are 36, carry 3. 6 2s are 12 plus 3, 15, 5 carry 1. And 6 4s are 24 plus 1, 25. Hence, I am getting an exact value of 2556, remainder 0. I complete this step by adding 6 to itself, and I leave the answer as 432. Hence, my quotient or the square root of 46656 is 216. Therefore, square root of 46,656 equals to 260. So let us learn how to find the square root of decimal numbers. So now the decimal numbers works a little differently. Alright, let's say I have to find the square root of 605.16. Now we will begin in a similar fashion where we will write down the number and square root we need to find out. Now the pairing up we will do would be separate for the decimals and separate for the integral part. Alright, now when we look at the decimal part, we need to always ensure that we have even number of digits. Alright, if there are no even number of digits, we will make it an even number of digits by adding a 0 to it. Right? Now since over here 1, 6, there are 2 digits which are even number of digits, I don't need to worry about it. So I make a pair of 2 digits here. Now I go on to the integral part, I make a pair of 2 digits. The last one, if it is single, not an issue. Yeah, but the decimal part should always be in pair of 2. Yeah. And then after this, whatever steps we do is exactly identical to the steps that we did earlier for whole numbers. Alright, so we begin with in the same fashion where we look at 6 and ask ourselves the question, square of which number will give you a number less than or equal to 6. So 2 2s are 4. So I write here like this, subtract it, the remainder is 2. I add 2 to itself, so 4, and I leave a blank. Then I bring down the next pair of digits, 0, 5. Now be careful, the decimal is not yet arrived. We have not yet arrived at the decimals. We are still on the integral part. Now we ask ourselves the question, 4 dash into dash should give you a number less than or equal to 205. So if I look at 5, okay, let's try 45 into 5. 5 5s are 25, remainder 2. 5 4s are 20 plus 2 is 225, which is greater than 205. Hence I go a digit lower. So I take 44 into 4 will give you 176. So 4s are 176. I subtract. This becomes 1, this becomes 9, this becomes 15. 15 minus 6 is 9, 9 minus 7 is 2, and 0. Now I add 4 to the number, so I get 48 and I leave a blank. Now comes the decimal, so I'll just simply put a decimal point on top, that's it. And I bring down 16, just normally. I do not put any decimal here, just here in my quotient. Alright, this is where our quotient would come. Now I'll ask myself, 4 8 dash into dash should give a number less than or equal to 2916. 4, yes, but then if you notice, this is 29, and if I multiply by 4 over here and here, I will get 4 4s are 16, so it will definitely not be close to that. But if I put here 6, I know 6 4s is 24, which is closer to 29. So my odds of getting 6 as the right answer are better. Right? So 486 into 6, if I try, 6 6s are 36, remainder 3. 6 8s are 48 plus 3, 51, 1 carry 5. 6 4s are 24 plus 5, 29. Hence, 486 into 6 gives you 2916. My remainder is 0, so I know it's a perfect square. I just complete this step by adding 6 and I get 492. and if you look at it, it is the double of 24.6. Hence, my square root of 605.16 will be equal to 24.6. Clear? Now let's look at another one. If I have to find the square root of 0.000729, I'll do it exactly in the same fashion. So 0.000729. Here I'll ensure that the number of decimal places are even. So there are 6 decimal places, so there are even number of digits. So I'll start pairing it up from the right hand side. 29, 07 and 00. Even 00 is a pair. Right? And in the integral part, there's only 0. So square of which number gives you a number less than or equal to 0? 0. So 0, 0s are 0. Subtract 0. Do this step even though it is redundant, but to maintain the continuity and the flow, it is better. Right? So my remainder is 0. I add 0. So there won't be any 0 dash. Now after this 0 comes the decimal, so I put a decimal. Now I bring down 2 zeros. So again 0 zeros are 0. I'll subtract 0. I'll get a remainder 0. I add 0. 0. That's it. Now I bring down 07. James Bond 007. So now, square of which number will give you a number less than or equal to 7? 2 2s is 4 because 3 3s is 9. So 2 2s are 4. Remainder 3. I add 2. So I get 4. And now I bring down 29. And I put a dash here. So I ask myself this question. 4 dash into dash should give you a number less than or equal to 329. Now if you put 3, you will get only 12. But then it doesn't end in 9. Number should end in 9. See, a product of which number would give you a number ending in 9? 3 3s is 9 and 7 7s is 49. So if it's not 3, it's most likely 47 into 7. 7 7s are 49, carry 4. 7 4s are 28 plus 4, 32. That's how you do it. Got it? These are simple tricks that you can get. So 47 into 7 gives you 329. Remainder 0. I just complete this step by adding 7. 54. So therefore, square root of 0.000729 will be equal to 0.027. So see over here, if you notice, there are 6 decimal places in the square root, but when I find the square root, there are 3 decimal places. So the answer will always have half the number of decimal places. That is why we need even number of decimal places over here. Yeah, are we clear about it? So now let us deal with numbers which are actually not perfect squares. Right? That means we are not going to get their exact square root. In other words, we'll never get the remainder as 0. So let's say if we have to find the square root of 24.729 correct to 2 decimal places, then how do we go about it? Alright, first things first, we write down the number whose square root we need to find. put it under the roof. Now we check the number of decimal places we have. There are 3 decimal places, but we need even number of decimal places, correct? So I would add a 0 to make it even. But now if we have a closer look at the question, they're telling us to find the square root correct to 2 decimal places. So whenever they ask us to find the square root of a number up to, let's say, 2 decimal places, we will always find it up to 3 decimal places. Means we'll find it 1 more decimal place and then round it off to 2. Correct. So we need total 3 pairs of decimal numbers so that I get 3 decimal places. Hence I add a total of 3 zeros and now start making the pairs. So 0 0 9 0 72 and here we have 24, sorry. Clear? And then the process remains the same. The only difference is that at the end we will not get a remainder as 0. But once we have finished exhausting all our decimal places, we leave the remainder the way it is, and a final answer will, as usual, will always be over here. So we begin. 5 5s is 25, so 4 4s is 16. Square of 4 gives you a number less than or equal to 24. So we subtract it from by 16. So remainder is 8. I add 4. So 4 plus 4 is 8. I leave a dash. Now there is a decimal point over here. So I put a decimal and I bring down 72. So I ask myself, 8 dash into dash should give you a number less than or equal to 870. 9. So that's the largest digit that we can put. So 9 9s are 81. Carry 8. 9 8s are 72 plus 8 is 80. So I get 89 into 9 is 801. So I subtract it, I get the remainder as 71. I add 9 to itself and I get 98 and I leave a blank. Now I bring down my next pair of digits as 90. So now I ask myself, 98 dash into dash should give you a number less than or equal to 7190. So what digit do you think we will fill over here? 0. But if I put 0, 980 into 0 will give me 0. 981 into 1 is 981, but I need 7190. That's quite a big number. See, if I look at 71 and 9, 9 into what gives you a number close to 71? 7. So let me try 7. That's how we always look at it. Look at the first 2 digits here and the first digit here. So 7 7s are 49. Carry 4. 7 8s is 56 plus 4, 60. 0 carry 6. And 7 9s are 63 plus 6, 69. So this is closest to 7190. So 987 into 7 gives us 6909. And I can subtract this 6909 from 7190. So I'll make this 8. This becomes 10. Remainder 1. 8. This becomes 6. I make this 11. 11 minus 9 is 2. I add 7 to it. So I get 994. Leave a blank. Now I bring my last pair of 2 digits, or last pair of digits. So now when I multiply 994 dash into dash should give you a number less than or equal to 28,100. So if I look at it, maybe 3 can work. Let's see if that works. So 3 3s are 9, 3 4s are 12, 2 carry 1, 3 9s are 27 plus 1, 28, carry 2. 3 9s are 27 plus 2, 29. So I go a digit lower, hence it would be 9942 into 2 should give you 2 2s are 4, 2 4s are 8, 9 2s are 18, 8 carry 1, 2 9s are 18 plus 1 19. So it will be 2, 2, 19884. We subtract it. This becomes 0, 9, 10. So this is 6, 1. This becomes 7 and 10, 2. This becomes 1 and 7, 8. And I add 2. So I get 9944. So therefore, square root of 24.729 is 4.972. But since they are asking us to find out up to 2 decimal places, I will look at my third digit. Since it is less than 5, I
4.97.
correct. So if it is 5 or more, we let it so. 4 or less, we let it rest. So 2 is 4 or less, so we let it rest. So 4.7. That would be the approximate value. Clear? Now let's look at this sum. Find the least number that must be subtracted from 2433 so that the remainder is a perfect square. So in this case, what I need to do is that I need to find the square root using the long division method. Now since this is definitely not a perfect square, I'll get a remainder, and that remainder, if I subtract it from 2433, it would become a perfect square. So let me find the square root of 2433. So in here I will not put any decimal places because I need to see what the remainder is. So I simply pair up 4 4s are 60, 5 5s are 25, so 4 4s are 60. So remainder 8. I add 4 to itself, 8 dash, and I bring down 33. And if I ask myself, this question 8 dash multiplied by dash should give a number close to 833, then let's try 989 into 9. 9 9s are 81, 1 carry 8, 9 8s are 72 plus 8, 80. So I get 89 into 9 as 801. That means my remainder is 32. That means if I were to subtract this 32 from 2433 or make 2433 less by 32, then the remainder that I would get would be automatically a perfect square. Correct? So I will say, therefore, this is my quotient, this is my remainder. If 32 is subtracted from 2433, the remainder will be a perfect square. Clear? This is a very fairly simple technique. Understood this sum? So whenever they ask us this question, kind of a question, where we need to find out the perfect square after subtracting the remainder or the least number, then this is the method. Now let's look at this. This is a little tricky one. Find the least number which must be added to 18,265 to obtain a perfect square. So in this case as well, we will first go ahead and find out what's the square root of 18,265. So I'll pair it up 6, 5, 2, 8 and 1 would be available. So 1 ones are 1, remainder 0. I add 1 to itself, 2 dash, I bring down 82. 24 into 4 is 96. So I will take 23 into 3 is 69. So the remainder would be 13. I add 3 to 23 and I get 26 dash, and I bring down 65. So 26 dash into dash should give you a number less than or equal to 1365. So I will try 2s are 2 2s are 4. Sorry, not 2. 2 is too small a number. So we can try 5. 5 5s are 25, carry 2. 5 6 are 30 plus 2, 32, carry 3. 5 2s are 10 plus 3, 30. So I get a number close enough, is 1325. Hence my remainder is 40. Now what do we do? Now you can't say, so we will add 40, because by adding 40 it doesn't become a perfect square. If I subtract 40 from 18,265, then 18,225 would be a perfect square. But we need to find the least number which must be added. Now see, over here, if you will notice, 18,265 is greater than 135, because definitely if I were to solve it further and find my square root in decimals, I would get 135 point some decimal number, correct? So I can say clearly 18,265 will lie between 135 square and 136 square. It has to be less than 136 square, because it will be 135 point something something, correct? That means, since I need to find the least number which must be added, so I will find out what will I add to 18,265 so that it becomes the square of 136. So I will find out what is 136 into 136. And that would be 18,496. Correct? So therefore, the number to be added to make 18,265, or to obtain a perfect square, will be nothing but 18,496 minus 18,265. Remember 1, 3, 2. So 231 will be the least number that I will add.